Hello there, so welcome back to the channel and welcome to day 39 of our Python learning challenge. So the goal and objective of this challenge is to learn and master Python over the next 100 days. So we actually set a target of 100 days to cover the career track data analyst with Python on the DataCamp platform. So we are on our sixth course out of 9 courses in the whole career track. We're on the sixth course. So hopefully as we are going, we may probably complete the whole career track before day 100. That's the goal. But the bone of contention is to just set a target of 100 days and follow the curriculum on the platform to learn and master our Python as a data analyst. So it has a lot of project also, a lot of tasks that you can play with and get your hands dirty as you learn along. That's one of the reasons I'm definitely using the platform. So they get it now. So we are on the course called Joining Data with Pandas, where we're actually learning how to join and merge data together. Probably you have a data in one table, you have some data in another table, and you're looking to join them together in Python. Bulk markets, those are those data types or those type of data are referred to as time series data. So that's what we are learning in this final chapter. So we hope to complete this whole lesson today and move to the next course in the next live stream. But I think the next course is a project. Probably a project for us to get our hands dirty and practice what we've covered so far in the first few or sixth course that we've covered so far. So if you want to learn how to merge data from scratch from the beginning, I'll encourage you to go and start from this data merging basics so you understand what merging data looks like in Python. Or if you're looking to start Python from basic, where you get introduced to variables or lists or tuples, data types, and all those basic stuff, and just go to day one of this Python learning challenge on the YouTube channel. Just go to Excel Island YouTube channel. You pick up from day one, then you can also practice and learn along with me. So you also see a lot of lessons there. So without any other introduction, let's continue from where we stopped yesterday. So we've covered these few lessons in the last two live stream. That's day 37 and 38. So let's see if we can complete this part of the lesson on today's live stream. Okay.
Now that you have learned quite a bit about combining data from different data sources, let's review a Pandas method for selecting data from a table called the query method. Pandas provides many methods for selecting data, and query is one of them. The query method accepts an input string that will use to select rows to return from the table. For those familiar with SQL, the string you provide to the query function is similar to the portion after the where clause of a SQL statement. However, don't let the SQL statement scare you because prior knowledge of SQL isn't required. Let's look at an example. We have the following table named stocks with the stock price of Disney and Nike on different days. Now imagine we would like to select the rows where Nike is equal to or above 90. Here, we provide a string to the query method. The string identifies that we want to condition which rows are returned by the value of the Nike column. We simply input Nike greater than or equal to 90. The method returns all rows in stocks where Nike is greater than or equal to 90. Let's look at another example. Here, we use the AND keyword to select rows where Nike is greater than 90 and Disney is less than 140. The method returns 2 rows of data that match our criteria. Next, instead of using AND, we can also use the OR keyword. This input string should select all rows where Nike is over 96 or Disney is less than 98. Now the function returns 3 rows that meet our criteria. Our next example shows that you can use the query method to select strings. Imagine that we have an updated data set, which is the stocks table in a slightly different format. We are interested in selecting all of the rows where the column stock equals Disney or the column stock equals Nike and close is less than 90. Let's pause here for a moment to look at our query string. Within the parentheses of our string, we check if the stock column is Nike and the close column is less than 90. Both of these conditions have to be true for the parentheses section to return true. We then add to the condition to check if stock is listed as Disney. When checking text, we use the double equal sign similar to an if statement in Python. Also, when checking a text string, we use a double quotes to surround the word. This is to avoid unintentionally ending our string statement since we use single quotes to start the statement. In our results, we see all of our Disney rows return. Also, those rows where Nike is the stock name and the close price is less than 90 are returned. Now, it's time for you to try using the query method.
I think this query method is quite straightforward and simple. But if you understand SQL or conditional statements, this is an easy task to do. So the data we'll be using here is social fin, but challenge is that I don't have access to the data sets. If I come back here, so these are the data sets provided for this lesson. So some of it I have access to, some I don't. So what is this data set called here? It's called social data. I don't have any social data here. So that means we are just going to practice our lessons on the DataCamp platform here. So let's read what it has. So explore financials with dot query method. So you have been given a table of financial data from some popular social network company called SocialFin. All the values are in thousands of US dollars. Use the dot query method to explore SocialFin and select the two statements. This is wrong. So I can't, there's the way I can work with this slide here. I think so. I don't always get it. I can also code in this IPython shell, yeah, but I can't remember how to. That's not fair. Let me see. I think I need to press shift something. I can type the code. I can say dot query social fin. Let me give it a shot. Dot query open brackets. Then it says we should use social fin. So possible answer. Use dot query method to explore social fin and select the two statements. There are two rows where the value is greater than $550 million. There are 3 rows for total revenue for Facebook. There are 6 rows where the net income has a negative value. There are 45 rows where the gross profit is greater than 100K. Because I can't see. Oh, oh, hold on a minute, please. Yep, I'm back. Just a few seconds there. I need to attend to a message. So there's a way I could actually code in this Python environment here provided by DataCamp, but I can't remember that right now. But let me give it, I said I want to give it a shot earlier. So let's do it again. Uh, hmm, hmm. So this is incorrect. There are rows. There are rows to check this answer. Use the financial gross profit value in the query method. Okay, let's use this. Let me see if I can find a way to code this out. So social fin dot query. Then you are going to say this column equals to gross profit and value is less than. How do I run this line of code? Let me just press Ctrl Enter first. Shift Enter. Is it running? Shift Enter. I'm writing a line of code in. What about Alt Enter? No way. Come on. Show slide. There's a way to run this line of code in this environment. The same way I've been running line of code in my own Python when I use this button here to run the code. Shift Enter. I've pressed Shift Enter here and it is not running. Shift Enter is coming up with another line breakage there. So I'll probably just guess the answer though. Or just guess the answer. Definitely the last one. But there's a way. Press Enter to continue. That to check this answer, you need to select financial equal to net income and value less than 0. There's a technique for me to use this Python environment here just to view the data set. But I can't remember that. I said I want to just Google it. Let me quickly Google it if that is going to work. Just a few minutes. Or I could just ask, okay, hold on a minute. So I'm trying to Google how to run this line of code here using the IPython share provided by DataCamp. So it says click, it's actually click Shift Enter. So it is not running. So it's supposed to be Shift Enter. So it is saying Shift Enter, but it is not working yet. So I'll just ignore that and move on. So let's move on to this. So we can run the code here. So this is provided to run the code. I don't know why this IPython shell is not showing the result. But let's move on though. So subsetting rows with subquery. So subsetting is like calling out some rows. Maybe filtering. So subsetting like filtering in Excel or Power BI or SQL. So in this exercise, you will revisit GDP and population data for Australia and Sweden from the World Bank and expand on it using the dot query method. So interesting. GDP and population. I think I have those data sets in my here. GDP, this GDP here, World Bank GDP, and World Bank population. So we have this data set here. So that means we can run our own calculations, line of code here too. So we see what we are actually doing. So I could just call on the two data set again. GDP. Let me do that. GDP.head. Control C. GDP. This is it. Then that is the World Bank GDP data sets on some certain countries. You can see it here. No, this is it here. And this is GDP. You can see of the country name, the country code, the indicator, the year, and the GDP for that year. Also have the population of those countries also. Let me just copy this here and scroll down real quick. So we have these two data sets to analyze. So let's follow the instruction here. So you will merge the two tables and compute the GDP per capita. So we're going to merge the two tables together and compute the GDP per capita. Afterwards, you use the dot query method to subselect the rows and create a plot. Recall that you need to merge on multiple columns in the proper order. Okay, we're going to use merge ordered, and we covered merge ordered on a couple of live stream back, I see. Definitely on day 37. That was when we learned about merge ordered. So let's use it in this challenge. So using merge ordered on GDP and pop on columns country and date with the fill feature save to GDP pop. Okay, we want to merge the two tables together using certain instruction. Okay, so I'm going to say merge ordered. So it's going to be pd.read. So Pandas is already imported. So pd dot merge ordered. So the first table we want to merge is the GDP table. That will be our left table. We want to merge it to the right table, the pop table. On these two columns, country and dates. We want to merge it on two columns. Comma. Since it is on two columns, so I have to call on the square brackets, country and dates. Also, we need to be sure we have country and dates in my record here. If I check my own data set here, I have country or country name, country code. So this data set is quite different from what has been provided here. That is not fair. Country and date with the fill feature. Then we're going to mention fill method, comma fill method. So this fill method is going to fill in missing values for us. That will be FFIAL. So let's run the code and see. Oh, country is not defined. Oh, I think I need to write this in quotes. Yeah, my mistake there was not wrapping it in code. But I can see that was successful. If I try to merge it, let's submit and see. So we got that line of code. So if I try to perform the same scenario here, the challenge is that the country and date column. So what we have here is country name, but the challenge I can actually, let me see if I can have a look at what we have, the result of this merging. If you can see it here. So if I try to print, let me just do some nice idea. If I say print GDP, if I try to print this record here, what I do is all I have to do is just select it. Oh, why is not seeing it? Really? Okay, let me see. Let me select these two together. Aha. So you can see what we have here now. So this is my data set here. Let me just go up a little bit. Look at data. I have date. You can see the date here. The date is the first column here, followed by country. While the data set I have here, the date. So I can perform all of this analysis here also. That's not fair. So I'm just going to work on this environment alone. So this data set we have the date, country, GDP, series code, population, series, population. There is the GDP and the population and the series code for Y. So this is the result we have here. So let's just work with what we have here. Since I don't have data access to this data set mentioned here. So what we need to do now is to say add a column named GDP per capita to GDP pop that divides GDP by the population. So we want to divide this GDP column here. We want to divide it by the population to calculate GDP per capita. So that's what we want to do here. That's what we need to do this. Let's calculate the GDP per capita for a data set. So add a column named GDP per capita to GDP pop that divide the GDP by population. So I'm going to say pop, GDP pop, GDP pop, square bracket. We want to add a new column called GDP per capita. Okay. So that will be in quotes. Okay. Which is going to be the division of so that's going to be GDP. So GDP pop equals to GDP per capita is the new column I want to be created, and the result that will give me this GDP per capita is going to be GDP pop. Then select the words. This column here. What is the column I want to select there? Oh, I can't select it here. So I want to select the GDP column. GDP column from pop, from the population. Okay, GDP pop divided by GDP pop divided by the pop column. So that should give us the results of our GDP per capita. That's a simple division here. So I run the code. So you can see now if you look closely, so we took the GDP table column and we simply divided by voice GDP, this population column here, by a population column. So you have a new column called GDP per capita. So that's what this line of code is doing there. So as you can see from here, so the next one is pivot GDP pub. So values pivot GDP pub. So values equal to GDP per capita, index date, and columns country. Save as GDP pivot. How do we pivot that? So pivot table of GDP per capita, where index is date and column is country. Okay, let's see how to do that. So we have GDP pivot. So the data first. So we're taking GDP pop dot pivot table. It's going to be GDP per capita. Okay, this is the calculation we did here. The new column. It says pivot GDP pop. So values equals to GDP per capita. Index should be date and column should be country. So this should be for index and the column should be country. Interesting. Pivot table. Okay, so I will GDP pop. So our index here. I want to mention the index here. Will be the date as mentioned. I'm just going to copy this line of code here. So that is our index. Index equals to, while our column will be equal to country. I'm going to copy all this here. I'll just paste it there. So let's see what we have here. So our results should show our date column will be our first row. So our date column, this date column is going to be the first row, the first column rather as usual. Then the country will be the columns. So all this country that are here, they will not be the columns. They'll replace all the columns here. Okay, so we are just pivoting the table, the result. Let's run it and see. Okay, so I can just show you what it looks like a little bit. Let me just show you what that looks like real quick here. If I say print, let me just run a line of code that says print GDP pivots, GDP pivots. If I say print this, let's see. So you can see the result now. You can see the country is a column, while the date is the index. So you are seeing the results for Australia and Sweden. Interesting, but we don't want this here. I'll just get rid of that and submit this line of code. So let's submit the answer. So use dot query now to select rows from GDP pivot where date is greater than or equal to 199101, save as recent GDP pop. So I want to filter to only certain rows of data. Where select the dates equal to or greater than. So it's going to be where dates recent GDP pop is going to be our GDP pivot dot query. So it's going to be where dates, where date, the dates column. That's our dates column here. Oh, we're not seeing that. Where the dates column is greater than, select dates equal to or greater than. So that is be greater than or equal to 19 I think working with dates can be very funny. You need to use double quote there. Date is seen as text. So that's so date is seen as text. So let's see. Plot reset GDP. So let's run the code. Aha. You see the results. So let's submit probably to be sure we got it. Tada, straight up we got it. So date is in data text in data analytics in Excel, Power BI, SQL. You have to have dates in quotes because you can't even analyze it. You can't do any calculations on dates. You can't multiply, divide, or you can still do some basic calculation, but you can't do some normal analysis on dates on date record. So amazing. You can see that from the plot that the per capita GDP of Australia passed Sweden in 1992. Let's see 1992. You can see 1992 here from here. This is 1991. This is 1992. So the per capita or GDP of Australia passed Sweden. This is Australia. Australia is in orange. Sweden is in blue. So Australia is in blue rather. Sweden is in orange. By using this query method, we were able to select appropriate rows easily. The dot query method is easy to read and straightforward. Interesting. So let's continue. Let's see what we have here. So reshaping data with dot melts. So this is another lesson. Let's see what we need to learn here.
In our last lesson of the course, let's talk about the melt method. This method will unpivot a table from wide to long format. This is often a much more computer-friendly format, therefore making this a valuable method to know. Sometimes we will come across data where every row relates to one subject, and each column has different information about an attribute of that subject. Data formatted in this way is often called wide. There are other times when the information about one subject is found over many rows, and each row has one attribute about that subject. Data formatted in this way is often called long or tall. In general, wide formatted data is easier to read by people than long formatted. However, long formatted data is often more accessible for computers to work with. The melt method will allow us to unpivot or change the format of our dataset. In this image, we change the height and weight columns from their wide horizontal placement to a long vertical placement. To demonstrate the melt method, let's start with this dataset of financial metrics of two popular social media companies. Notice that the years are horizontal. Let's change them so that they are vertically placed. Here, we call the melt method on the table social fin. The first input argument to this method is ID vars. These are columns to be used as identifier variables. We can also think of them as columns in our original dataset that we do not want to change. In our output, we print the first 10 rows. Our years are listed vertically. Our final columns now has all our values in one column versus multiple columns. Again, this is much more computer-friendly format than our original table. We unpivoted each of the separate columns 2016 through 2019. Our output has data for every year in our starting table, but again, we are only showing the first couple of rows. In the next example, we will look at how to control what columns are unpivoted. This time, let's use the argument value vars with the melt method. This argument will allow us to control which columns are unpivoted. Here, we unpivot only 2018 and 2017 columns. Our output now only has data for the years 2018 and 2017. Additionally, the order of the value vars was kept. The output starts with 2018, then moves to 2017. Finally, notice that the columns with the years is now named variable, and the values column is named value. We will adjust that in our next example. In this example, we have added some additional inputs to our melt method. The var name argument will allow us to set the name of the year column in the output. Similarly, the value name argument will allow us to set the name of the value column in the output. We again print the first few rows of the output. It is the same as before, except our variable and value name columns are renamed year and dollars, respectively. We have seen how the melt method is useful for reshaping our tables. Imagine a situation where you have merged many columns, making your table very wide. The merge method can then be used to reshape that table into a more computer-friendly format. All right, time to practice.
So the melt method is just you have using like pivoting and unpivoting in Excel and Power BI. So I also perform pivoting and unpivoting in SQL. I'm not pretty sure of that. Probably I've forgotten. But I'm definitely sure of pivoting and unpivoting in Excel and Power BI. So this is what the melt method is for. So let's solve these last four challenges and we wrap up the course. Just a second, please. Okay, I'm coming. Okay, so let's see what we need to do for this challenge. So select the right dot melt arguments. So you have been given a table named inflation. Choose the option to get the same output as the table shown. Okay, we have the country, the indicator, the year, and the annual inflation. So the inflation indicator is shown in percentage, the years of the inflation, and the country uh, variable for that inflation. So let's see, inflation dot melt ID verse. So ID verse, we want to keep, we definitely want to keep the country record. We don't want to unpivot and the indicator. The year will definitely be pivoted, and the annual record also. So I'll go for this country and indicator definitely. Mm, So the name have been renamed. The year has been renamed actually. So the var name is indicator. Mm, This is wrong. var name can never be indicator. var name is definitely the year, and the value name is definitely that's the answer. Yeah, we nailed it. So magnificent. So you identify the correct values to pass to the ID verse arguments. So these columns are not unpivoted. Finally, the other arguments set the name for the year and value columns. So let's practice that and see. Oh, we've been learning for the past 39 days. Definitely over your 100 period of learning, or 100 days of learning, just practicing some stuff behind the scene. So let's continue. So we want to use the dot melt method to reshape to reshape government data rather. So the US Bureau of Labor Statistics (BLS) often provides data series in an easy to read format. It has a separate column for each month, and each year is a different row. So there's a separate column for each month, and each year is a different row. Unfortunately, this wide format makes it difficult to plot this information over time. In this exercise, you will reshape a table of US unemployment rate data from the Bureau of Labor Statistics into a form you can plot using the smelts. You will need to add a date column to the table and sort by it to plot the data correctly. So the unemployment rate data has been loaded for you in a table called your wide. You are encouraged to explore this table before beginning the exercise. So how do I explore the table? Oh, I think I know how to explore the table first. So let's explore the table first and see what we have there. And we can do that by printing. Let us print your wide. No way. E underscore wide. Let's see if you can see that. Ah, voila. So we could see it. So this is the data set we want to work with. So we have the year, the months. You can see the months are the columns. So we just definitely need to unpivot all these months. So there will be by rows. Then the values. So at the end of the day, we'll be having just two columns rather than almost January to November is 12 plus 1, 13 column. So we'll be having the year column, the months, and the value for those months. So definitely we're having three columns. Year, year definitely, then the months, then the values for those months. So let's see how to do that. So I'll just get rid of this print line of code here. So unpivot everything beside the year column. So definitely everything beside the year column. I want to unpivot everything beside this year column. So we're going to say your world, year underscore world dot melt melt arguments. So we want to keep ID verse. We want to mention the columns we want to keep first. ID verse equals to our year column. We are not on pivoting the year, this year column, we are not on pivoting it. Then that should be all. It's as simple as that. That's just basic on pivoting. Now, if I run this line of code, let me run this line of code. I shouldn't get any error. So if I now print, let us now print your tool here. Your tool, can you see now? I'll just print this your tool. Voila, I can see we have three columns now. The year, the variable, and the value. So our variable are the months that has been unpivoted. So from columns, they've been unpivoted to become row records. They have the value corresponding to what? To each month. You can see January is 9.8, 9.1. So you see 9.8, 9.1 here. So that's basically what we did with this line of code here. Right, I'll just clean that line of code. So now we're going to create a date column using the month and year columns of your tool. So from this year and month record, this variable, we're going to create, I need to go back here. I didn't get the instruction completely. So use .melt to unpivot all of the columns of your word except year and ensure that the column with the months and values are named month and unemployment rate. So we need to go back here and give this value name, comma, let me just say value underscore name. Just a minute there. So value underscore. So we want to rename this variable name. We want to name it month, and this should be named unemployment rate, this value. So it's going to be value name, that would be equal to months. So sorry, this will be var name. That is the variable name. So variable name should be named to months, and the value name, so value underscore name, value underscore name, that would be equal to unemployment rates, as mentioned there. I'll just back a little bit. So if I run this line of code, let's run this line of code here. So then if I try to print, we should have a better result now. If I write print your tour, I'll just let this line of code to print only those. You can see it now. So let's see, you can see year, month, unemployment rate. And we have our record here. So from this bigger, wider column, so we've unpivoted it to longer, taller columns with few number of rows. So the next instruction says add a column to your tool, name date, which combines the year and month. So we want to combine this year and month record into one single column named dates. So how do we do that? Let me just get rid of this print. So create a dates column using the month and year column. Okay, so it's going to be your tour. Then we want to create a new date. So to do that, pd dot date time your tour. That is going to be the year column, the year column, and the month column. And the month column exactly. So it's just going to be an hyphen in between those records. Now let me run this line of code. Let's run this line of code and see. Ooh, name month. Month is not defined. What do you mean month is not defined? Oh, I didn't put this month. Okay, this one is going to be your tour. So I didn't do that correctly. Your tour brackets brackets. And let's do it again. Voila. So we shouldn't get any error right now. So if I try to print this your tour one more time, let's print your tour. Let's see if we've actually added a new column to this record here. It's going to be print your tour. All I have to do is select this line of code and run it. Well, I can see we have year, month, unemployment rate, and the dates. You can see in between those dates, there's hyphen, as is mentioned here. So now we are on track. Let's sort the records. Sort your tour by date in ascending order. So the next instruction says use sort using your tour dot sort plot on. Okay, sort your tour by date and save as you are sorted. So I want to sort it by date. It's going to be your tour dot sort value. Yes, sort underscore value. Sort underscore value. Sort underscore values. So I want to sort by the dates column that we've mentioned here. I'm going to open a bracket there. So by dates. So it's supposed to be sorted in ascending order. So ascending order is going to be, I'm going to mention ascending equals to 2 there. And let's run this line of code and see the results. So that is correct. Oh, there was an error. No, there's definitely no error there. So if I run print your sorted, so if I run the second line of code here, this code, we just want to see the results. You can see now. So this is going from the what? Highest to the lowest. You can see 001, 001, 02, 01, 03, 01, 04, 01, 05, 01, and so on like that. See all the way to 2020. You can see from 2010, it goes to 2011, all the way down. So that's what we've done with this line of code here. So if you move to the next instruction, so using this data frame, you're sorted that we've sorted, plot unemployment rate on the y-axis and date on the x-axis. So plot unemployment rate on the y-axis. So I want to plot a graph. So it's going to be plot on the y-axis and date on the x-axis. So our plot is going to be uh definitely our kind, definitely a line chart. I'm going to use a line chart for this. Let's see. We don't even need to mention any chart. Let's see. So plot unemployment rate on the y-axis and date on the x-axis. Let's say x-axis equals to dates, then comma y-axis, that should be equal to unemployment rates. So we don't need to design or color code our chart now. Let's run all this code and see. Ta-da! Voila, we have our results. You can see unemployment rate by dates. You can see from 2011. Is this wide enough? Let me make it a little bit smaller. Uh, you can see this from 2010, 2011, 2012. You can see I think unemployment rate dropped over the years, as you can see here. So that's how we could just use this simple Python environment for. Let's submit the answer and see. Then we nailed it. So you can see, so nice going. So the plot shows a steady decrease in the unemployment rates with an increase near the end. Okay, you can see there's an increase near the end. This increase is likely the effect of COVID-19. Definitely that's around 2019, 2020. If you look at the results, this is around 2019, where everyone was at home. Yeah, definitely. And its impact on shutting down most of the US economy. In general, data is often provided, especially by governments, in a format that is easily read by people, but not machines. So you can use the dot melt method in a handy tool. So the dot melt method is a handy tool for reshaping data into a useful form. So definitely the dot melt method allows you to make your rows, your data that are in longer rows, make it longer. Sorry, your data that are provided in a wider columns, you make it shorter, longer within in rows, and that is one of the best ways to work with data sets. I hope that makes sense though. Let's continue and see what we need to do in this challenge. So we spent almost 1 hour. Let's okay, this is the last challenge. Using dot melt for stocks versus bond performance. So let's solve this challenge. Oh, we have a lot of instructions to follow. 1, 2, 3, 4. Let's give it a shot and see. So we want to use the dot melt method one more time. So it is widespread knowledge that the price of bonds is inversely related to the price of stocks. In this last exercise, you will review many of the topics in this chapter to confirm this. You have been given a table of percent change of the US 10-year Treasury bond price. It is in a wide format where there is a separate column for each year. You will need to use the dot merge method to reshape this table. So additionally, you will use the dot query method to filter out the unneeded data. You will merge this table with a table of the percent change of Dow Jones Industry Stock Index price. Finally, you will plot the data. Ooh, that's a lot of steps to take. So let's give it a shot. So the table 10-year and DJI have been loaded for you. So first of all, we need to use the dot melt method. I'm just going to run through the codes, but probably I'll not show you the result. We can just use dot print to see the result of each line of code though. Or just after the final results. So let's see. So use dot melt on 10-year to unpivot everything except the metric column. Setting variable name to date and value name close. Save the result as bond PCSV. So let's give it a shot. Let's use dot melt. So it's going to be the 10-year data set. Dot melt, which is going to be equals to, I need to mention those columns I don't want to unpivot. These columns I want to leave as it is. So it's going to be ID vars bracket. I don't want to unpivot the metric column. So I don't want to turn it from column to rows. So that's what unpivot means. Then the values name, I want to change this variable name to date and value name to close. It's as simple as that. Pretty straightforward. Let's get rid of this and line of code there. And I think that's all. So that's all, everything there. So now we're going to use the using the query method. Select only those rows where metric equals close and save to bond per close. Okay, want to use the query method to return certain number of rows. So we're going to say use query on bond to select only rows where metric equals to close. So that is going to be bond per close dot query, open brackets. So we want to select only where the metric column, or the metric column equals to close. So that's what we need to do there. It's as simple as that. Then the next line of code is to merge. Use merge order to merge DGI table. So I want to use merge ordered. So I want to use merge ordered. So the final step is to use merge order there. Merge ordered. So double bond. So I want to use PD dot merge ordered. Merge ordered. So our left table is our to merge DGI the left table to our bond per close table. On which column? On dates with an inner join. Our common column here is the dates column. So this I want to use an inner join. Our join type, so our how is going to be inner. Then want to add some suffixes just to differentiate the column. Then finally, and set suffixes equals to suffixes column. That should be equal to this do and bond just to differentiate the columns. Then finally, I'm going to close that with a bracket. Okay, we have one bracket here already. We have brackets here already. Then finally, we have the bracket there already. So plot only the closed door and closed bond columns. So dot plot closed door and closed bond column. Ooh, I want to plot only the door and bond value. Okay. So one is going to be our x-axis. So they're definitely going to be on both x and y axis. Right, or both y axis rather. Let's see. So that means our x-axis is the dates. So I want to see the closed door and those bond on the y-axis. Okay, so I'm going to mention y-axis is going to be equals to, since I want two columns there, I want to introduce the brackets here. So close door, then comma, close bond, close bond. Let's run the code and see if you're on track. Oh, there's an error somewhere. Let's get error. There's an error somewhere. Definitely, we're expecting an error from somewhere. So our error comes from this bond pack. ID verse. Oh, since I'm mentioning just one column, I don't need to put it in. Oh, my mistake was from here. Since it is one column, I don't need to put it in square brackets. Let's run that again. Oh, come on. Okay, let's just get help on the error again. ID verse equals to, I need to pay attention there. Equals to this. Okay. So the problem is that you are using operator instead of calling melts. Oh. Oh, okay. Melts. Oh, come on. Supposed to be square bracket there. Dot melt. Then, oh, sorry about that. Voila. So you can see my mistake was just in the first line of code. So this is the result we needed to see. You can see that. So we plotted closed door and closed bond just to record there. You can see that the closed bond is definitely a little bit higher in 20 between 2008 and 2009. So you can see that. Let's submit that line of code and see. Super job. You use many of the techniques we have reviewed in this chapter to produce the plots. So the plot confirms that the bond and stock price are inversely correlated. Often as the price of stock increases, the price of stock decreases. So you can see that from the yellow and the blue line of code. So interesting. So learning all about our journey data with pandas has been interesting because we covered quite a lot of stuff from merging to on pivot to reshaping and so on. Let's listen to the course wrap. Let's wrap up.
Congratulations! You have completed all of the videos and exercises. You should feel proud. It wasn't long ago when you started the course. Now you're like this high performance race car when it comes to combining data. In this course, we covered a lot of topics. In Chapter 1, you performed an inner join with the default settings using the merge method. You also learned about the different types of table relationships and how to merge multiple tables. These are the basics of combining data with the merge method. In the second chapter, you expanded your joining skills to many different types of joins. You also learned how to merge a table to itself and how to merge using indexes. In the third chapter, you learn about filtering joins, such as semi and anti joins. You also learn how to combine data vertically with the cat method and about the importance of data integrity. In the last chapter, you discover how to merge ordered and time series data with merge ordered and merge as of. In the last lesson, you learn how to use melt. Thank you for completing the course and for the time you have put in. I wish you luck as you continue your learning journey.
All right, so that was all. So we have completed merging other data and time series data. Oops, interesting. So I think our next course now is Introduction to Statistics in Python. Interesting. So what we're looking at now is statistics in Python, but there's statistics in almost in Excel, Power BI, SQL. So let's see what we are going to learn here. So we're going to continue from this lesson on day 40. So what is statistics? Let's see if you look at the career track section real quick here. So we are now on data analysis in Python. So we have to learn all about statistics next. Introduction to statistics, which is course number 7. We have summary statistics, random numbers and probability, mode distribution and central limit theorem, correlation and experimental design. Hmm. We'll move to Seaborn. Definitely looking forward to. We've learned matplotlib for data visualization. You can see here. Oh, come on. So we're now looking at Seaborn here. They move to data manipulation with this is an project, then an assignment, then another project, then data analysis with Python EDA. This EDA. Then we are going to analyze crime in Los Angeles, sampling in Python, hypothesis testing in Python. All right, looking forward to all these lessons and challenges. So that'll be the end of the live stream for today. So if you learned one or two things in this journey data with Python, do want to give this video a thumbs up, hit that subscribe button, and I'll see you on the next video in the channel, and I'll see you on the next day live stream as we start statistics in Python. Have a wonderful rest of the day.